Aloha, Richard Halverson here. This is ITS228, and today I'd like to go over the shortest path problem, your assignment 6. So first, let me share my screen. And I am referring to assignment 6. Okay, so this is the shortest path problem. You should see it in your chapter 10. Let's go to my chapter 10 here, zybooks.com. (228) chapter 10 graphs. This is Dijkstra's shortest path problem. So the way Dijkstra's shortest path problem works is that what the algorithm does is it figures out the shortest path, okay, in a graph. Okay, we have a graph here. A graph is it's like a tree, except for things can link back to other nodes already in the graph. So so this is a graph. This is a graph. And what Dijkstra's algorithm does is it calculates the shortest path from each node from a starting node. So if we start from A, let's say we're going to start from A, what Dijkstra's shortest path algorithm does is it calculates the distance to A from C, the distance to A from D, and the distance back to A from C, the distance back to A from D, and the distance back to A from B. No, it's not the distance. No, it is the distance too. It's the distance because in a graph that where the path from, let's say, B to C costs 5 units, but the path from C to B could cost a different number of units. So there is a distinction. So what Dijkstra's algorithm does is it calculates from A, the distance from A to C, the distance from A to D, and the distance from A to B. And then after that, you can ask the graph the distance from A to any point, and the graph can then an algorithm can once this information has been tallied for each of the nodes. This is the distance. This is the distance from B. This is the distance from A to B, and it goes through B. So you go back to here. Here, this is the distance from A to D, and the distance is 4, and you go back by way of B. So you go back to B, and then you can see the distance from B to A. But the number here, the letter is the node that you go back to calculate the distance, the total distance that you're trying to calculate. And this is what the actual value is for the number of units that it costs to get to that node. That probably didn't make too much sense, but you can, so here's an example of going from C to E is 8, but going from E back to C is only 4. And so this has you, make sure you understand how Dijkstra's algorithm, shortest path algorithm works. From a particular node, it first calculates the distance from that node to all the other nodes, to each of the other nodes. And once it's done with that, then you can ask it, how far is it from A to D? How far is it from A to any node? And it's able to, in O of n steps, just follow the nodes back, and it can tell you not only the path, but the how much it's going to cost. These distance values. These can be, cost of the ticket to fly. That can be the actual distance. It can be the amount of gas that it takes. All kinds of things. But anyway, so that's this is the shortest path algorithm, and this is a very important algorithm to understand at this level of computer programming that you're studying. And what we're going to do is, in the next chapter, we look at the Python version of Dijkstra's shortest path. And the first thing I ask you to do is to implement this example 10.13.1, which is this example right here. So I have you first step is to implement this on your server. That's you know, a fifth of the points. And then the second part is to actually modify the program. So the program will ask you a start vertex and an end vertex, and it will display out the path and the cost to get to from the start to the end. And so here's some examples of the run for main 2. First, you're going to implement main 1, and that's just this. Let me show it to you. You can just execute this program here. Don't have no input. Just execute the program. And what this program does is it calculates the shortest path from A to A to B, A to C, A to D, A to E, A to F, and A to G for this graph. It's this graph. So the first thing it does is it has to, if you look at the code here, this is Dijkstra's shortest path algorithm. This is how you get the shortest path. You have a beginning vertex and an ending vertex, and this is what calculates it. You know, it does the algorithm here. Let's say it's from A to from A to G. Let's say. Dijkstra's algorithm tallies up the distances from A to each of the nodes and finally ending up with G. And so once that's complete, then to figure out the distance from A to G is you just start with G and you follow the nodes back to A. And and this actually is what creates this output. So if you're looking for the shortest path from, let's say, A to F, then what this method does is first it's going to you know, discover this path, and then it's going to discover this path, and then it's going to discover this path, and then it's going to finally discover this path. And when it's at F, it's going to say go to E, and so then this is what's added on, and that's why you'll notice each time there's a new path to be added, it gets added to the beginning. See, it gets concatenated to the beginning of the path variable as this thing iterates through the vertices. So it starts at the end vertex at F. This is where you want to go, and F is going to tell you E, and so then this gets added, and then E is going to tell you C, and then this gets added, and C is going to tell you D, and this gets added, and then D is going to tell you A, and then this gets added, and then it's output. So that's how this basically how this algorithm works. You should understand that, and we're going to first implement this, and then we're going to modify this program. Here we build the graph. There's 1, 2, 3, 4, 5, 6, 7 vertices. 1, 2, 3, 4, 5, 6, 7 vertices, and then there's these distances or these weights between the vertices. It's the weight or the distance or how expensive it is to go from A to B. It costs 8. To go from B to E, it costs 6, and so on. So this first declares the existence of the seven vertices, calling it A, B, C, D, E, F, G, and it uses this vertex class, which it gets from graph.py. So graph.py is here. It's got the vertex class, and all the vertex, a vertex just has a label, and then a distance, back. This is a distance that's calculated, which is, heading its way back to the starting vertex. And then this is what actual vertex you come from. And so of course it's initialized at none, as none. And then each time the Dijkstra's algorithm goes through and fills in these values for each vertex. It fills in what the predecessor vertex is and then what the distance was. And then this is the graph class. You're building a graph, and the graph class has got it's a list, and there's an adjacency list and the edge weights, and you can add a vertex to the graph. So you add a node. You can add a directed edge, which means it's just one direction from A to B and not from B to A. Or you can add an undirected edge, which goes in both directions. You see this adds the edge in both directions. So that's what this vertex and the graph. This is what the graph.py file has. It's got these two classes in it. And so these are used for here. First, we have to create the seven vertexes or vertices, and then we add the vertexes to the graph, and then we add the edges. Okay, so first we add these first we create these seven vertices, then we make them part of the graph, this entire graph entity, and then the last thing we do is we add the edges. And this thing adds the edges. And then we run Dijkstra's shortest path algorithm, and that is going to, starting from vertex A on graph G, this is graph G, we're calling the graph G. And so what this algorithm does is it goes in and it fills in these the label, the distance, and the previous vertex. And once that's filled in, then you're able to once that's all filled in, then you're able to go through one vertex at a time. And what we do is we sort them so they're in nice A, B, C, D, E, F, G order. And we calculate what the distance is between the starting vertex, which is always A. It's always A, from the starting vertex to the vertex that we're looping. We're looping through all the vertices A, B, C, D, E, F, G, and this will get the shortest path from the beginning vertex, from vertex A all the way to the one that we're generating, and that's what produces this table. First, we do A, B, C, D, E, F, G. Of course, the distance from A to A is 0. We're already there. And then we do B, and it's that. And we do C, and it's that. We do D, it's that, and so on. And so these are generated one by one as this loop goes through looping. And this is the line here. This is A to whatever S is. S is going to be, S is, must be the label, the V label. That's this thing, the label of the vertex, and so on. All right, so let's get this running on our server. I've logged into my cPanel, and let's go to File Manager. And so let's go to my assignments folder, and I don't have anything in there because I'm just going to start from scratch here. And so the first thing I'm going to do is create a folder called 6, and then create main and graph.py and copy the files over and get that to work. So I'm gonna do this. I'm gonna put this on this side, and I'm gonna pull this out. Put it on this side. Does that work? Anyway, so this is what I'm copying. So here I am, an empty directory. I'm in the assignments directory. So I'm going to create another folder called 6. So now I've got 6 in assignments and 6, and then inside 6, I'm going to create main.py and graph.py. So these are files, main.py and graph.py. No, I don't have that virus that's floating around these days. All right, so I'm gonna go to main, open it up, edit, and this is a blank one. I'm gonna go to main. I'm just gonna copy all this. I'm gonna go to the top, select it. All the way down to the bottom. Shift, click, copy, paste, and that looks pretty good. Throw another empty line. Okay, good. I'm just going to save the changes. And then I'm going to go back over here and I'm going to open up Graph. And I'm going to go over here to Graph. And I'm going to copy this. I'm going to do Control A, Control C, click Control V. There we go. And there's my graph.py with the 2 classes. Save changes. They're both saved, right? Yes. All right. So to run this, let's go back to cPanel. Where's my cPanel? Is it over here somewhere? Oh, yes, right. It's here. It's this one. Right, it's here. Okay, so go to cPanel, and I'm going to go to Terminal, and I'm going to open it up in a new tab. And I'm going to go to Assignments, CD Assignments /6, and ls-l shows me the 2 files. And I can run this Python 3 space main.py. And lo and behold, there it is. It runs nicely, easy. No problem at all. Great. Now let's do my let's go to the grader. That would be sp22.its228.com and put my name, and it's going to be this one, RICHA228 with my password there. And I'm going to click on Implement Shortest Path Demo down here, and now this can take a long time, especially when more than one person, or especially when multiple people are using a grading assistant or a auto grader at the same time. And all 3 of my classes use an auto grader. And this is the last week of class. You got till a week from, this is Monday, right? You got for a week to this is the first Monday of finals. You have another week to finish all this stuff. And so it can take a while. It actually logs in and runs the program. All right, so this is what it looks like, and we see that it goes to assignments, goes to 6, runs the program, and this is the output. And it does some checks. At first checks to make sure that this comes out, and then it makes sure that checks that this makes sure this comes out. And the reason it does that is because it's possible that you got these two working, but for some reason you messed up the rest of them, whatever, and you still get some points. And then this thing actually checks all the rest of them. And so if you get them all, then you get 10 points, and that's how many 10 out of 10, and so that's 20 for the, you know, scaled. So this one works fine. All right. So let's do the second one. And the second one is find the shortest path between two arbitrary vertexes. Okay, so first we're going to make a copy of main.py, and we're going to name it main2.py. And then we're going to modify main2.py. So the first thing it does is it asks the user what the starting vertex is. So in other words, it's not just A, it can be anything. It can be A, B, C, D, E, F, G. And then it asks, okay, so what that's going to do is that's going to affect, the starting vertex. See, this is hardwired to start at vertex A. And what we want to do is we want to make that a variable. So when we generate this, when we generate all the data for the graph using Dijkstra's algorithm, we won't be doing it starting from vertex A. We'll be doing it from starting from some other vertex, and then it's going to calculate the distance from all the other nodes back to that other defined starting vertex. and then that's the first part. And then when we ask the user for the end vertex, what this is going to do is this is going to have it so it only prints out the line for whatever the ending is. You see here, this thing prints out all of them. And what we want is let's say the input is A to G. Well, we would only want this one to print out. We wouldn't want any of these other ones to print out. Okay, so when we're writing our program, just know that this is gonna, we're changing it. So this is gonna define what the second argument in Dijkstra's method call is, with the second argument. And then this is gonna say, it's gonna filter out, we only want the one to G, and we don't care about B, C, D, E, or E or F. All right, so to do this, let's start by going back over here, and I'm done with this. I'm going to go back to here, and I'm done with this. Okay, I'm going to make a copy of main copy, and I'm going to call it /main2.py. Okay, now I've got main2.py, and let me open this up. All right, make this bigger. All right, so we aren't going to mess with any of this. We're not going to mess with any of this. We're just going to do everything down here. Now, the first thing is we want to be able to say, this is hardwired vertex A, and we want to be able to ask the user, let's call it start equals, so we want to ask the user input, enter start vertex. And we want it to be something between A, B, C, D, E, F, or G. A, B, C, D, E, F, or G, okay? We want it to be one of those. So that's the first thing we ask. I don't need two commas there. And as you might guess, I won't be looking directly for, I won't be looking for what you put here. I won't be looking for what you put here. The only thing is that the first thing you ask has got to be the start vertex, and the second thing you ask has got to be the end vertex. Okay, so you have to ask for the start vertex, put whatever you want here. You have to ask for the second vertex, put whatever you want here, and then it's going to output the answer. Make sure you don't change the graph or anything too, because I'm counting on you using this exact same graph. All right, so here we're asking what the start vertex is. And so we have that in a variable called start, but how do we convert that into this? Well, I tell you how we're gonna do that, how we're gonna do this. I'm gonna make this a list. Instead of hardwired 7 different variables, I'm gonna make it a list that's got 7 elements in the list. So vertex is gonna be a list. So I'm gonna go vertex equals a list. Yeah. And then I'm gonna say, instead of vertex underscore A, I'm gonna say vertex of A. So to do that, I'm going to change all of the underscores to a left bracket. A left bracket, single quote. So let's see if I can do this. I'm going to do Control H, and this thing pops up. Search for an underscore, and change it to a left bracket, single quote. I don't care about these underscores here or these underscores here. I only care about underscores that begin with vertex. So I'm going to change vertex underscore to vertex that. All right, so there's my first one. I'm going to replace, 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 replace. Replace, 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 replace. No, not replace. This doesn't matter. It's a comment anyway. Okay, so I got to do that, and then I got to change this side here. So I had to change. Well, I guess I'll just do these. I got to change space equals space to single quote back space equals space. So that would start, but I want to start here. So what happens if I press replace right here? No, it's not what I wanted. It's not that way. Put this back here, that back where it was. Undo this, okay. All right, right here, equals space vertex. See if that works. 1 of 7, okay, replace, 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 replace. Okay, that gets me that far. And then I need to, I just got to paste a bunch of these in there. Sorry, but this will make it a lot easier to do the rest of it. So basically you're changing all of the hardwired underscore A, B, C, D, E, F. And this can be tricky. Got to make sure you do this right. You can't make any mistakes. And there you can copy, I'm sure there's a, you can edit, you can do this up here for this with looking for a comma. you know, comma space. But you just got to make sure that all of the vertex underscore letter is replaced with vertex and have that letter be the array index. I'm sorry, the list index. Okay, so here we are. I'm gonna comment, turn this back into a comment, because this should work just exactly the same way. This should work the same as main.py right now. So I'm gonna save the changes. I'm done with this for now. And I'm gonna go back to my terminal here, and I'm gonna, instead of doing Python 3 main.py, I'm gonna do Python main 2.py. No, I'm not done yet. I gotta do this one. Done. Done. Is that it? Oh, I actually gotta do it. I gotta, because I want this to work the same, so I gotta do that. And same with this one here, I gotta do. All right, so this should work. It's vertex A, the adjacency list that's going to go through all of the letters of this. This is G adjacency list, which is, oh, that was created back up here, wasn't it? Yeah, this adds a vertex to the adjacency list. So it goes through all of these A, B, C, D, F, G, sorted. So it's sorted, and then if the predecessor vertex, okay, this is after this has been executed. Then this checks to see if the predecessor vertex of the V is none. Then that means there's no path. But in this case, it'll never be that. It'll be down here, and so then we're able to print. Okay, so I'm going to save changes. So this now should work. Main.py over here. Okay. Oh. It's an error. I got. This is just plain syntax errors. Too many of those there. Okay. Back here, up arrow, enter. Okay, hold on a second. Okay, I'm using the wrong Python data structure. Lists, defines a list, and the index of a list has got to be an integer, starting with 0, 0, 1, 2, 3, 4. I want the index not to be an integer, but whatever I want it to be. So that's a dictionary. So I'm using the wrong definition here. I want it to be a dictionary, which is two squigglies. So that defines vertex as a dictionary. So this should just, let's see if this works. Okay, there it works. Okay, so it works exactly the same as the other one, except for I have now all these vertexes are indexes. Okay, great. So I'm off to a nice running start here. So now I need to ask what the start vertex is, and then instead of it's going to be A, B, C, D, E, or instead of having it be just A, make it be whatever this is. So I'm going to replace A with this. Okay, because it's going to be A, B, C, D, E, F, G. And then let's see, so now it's going to be a different shortest path. And this will go from, okay, this is hardwired in as A. And we want it to be, that's because it's hardwired, it was hardwired to start at A. And we don't want it to be hardwired to start at A. We want it to be, hardwired to start at start. But start's got to be capital. Okay, we're gonna enter it in as a lowercase letter, and we actually want it to display out here as an uppercase letter. So let's just change this to, I'll tell you what I'm going to do. First of all, I'm going to make it just a lowercase letter. So I'm going to do start plus. And I'm doing that so we can watch what we're doing. And then I'm going to go back and I'm going to change that to an uppercase letter, which is easy to do. Start plus. Okay, so this is going to say whatever the starting letter is to whatever the to the sorted this thing is, and okay, all right, so let's, this should be a start right here. Okay, I'm going to save this and see. And okay, so what this does is this asks me for a starting vertex, but then it displays out the distance between all the other vertexes, the distance from all the other vertexes to the starting vertex. So if I go back to here and I run main2, the first thing is it's going to ask me a start vertex, and I'm going to put in a start vertex of A, because if I put in a start vertex of A, it should come out exactly what this is here. Okay, so I'm going to say A, and it's going to go like this, and it says, A to A is this, 8, 4, 3, 6, it's 8, 4, 3, 6, 10, 11. Yes, same. A. Okay. The only problem is this is lowercase. So let's make it uppercase. I just wanted to see, oh no, let's try first. Let's try a different vertex. Okay, I'm gonna go up arrow again, and I'm gonna say E. And we should see E to A be the same as A to E, and lo and behold, it is. A to E, and this is E to A. But then all these other ones are going to be different. Of course, E to E, no path exists. No, it says no path exists. Well, anyway, it turns out that the auto grader is never going to ask you the distance between two nodes that are the same. So when I wrote it, I wanted them all to be different. So that won't be a problem. But I was expecting it to come out the same as that. Let's try another one. Let's try B. Oh, no path exists. Okay. All right, so anyway, that looks good. Let's make this capital. So I'm gonna start, how do you make, it's upper, what's the Python string of Python, string uppercase. It's just upper, I guess, built-in method for strings. So I'm just gonna do that. I'm going to do upper dot upper, and I'll do it for this one too, dot upper, and save this and run this again. Let's do C, and there, now it's capital. All right. All right, so I just thought of something. Anyway, I think I found I think I just thought of a bug in my grader. Well, I'm not going to show it to you because I got to fix it before anybody starts using it. But but we don't want all of them. We only want the one that matches up with the end. Okay, so let me hold on a second. All right, so we don't want to output all of these. We only want to output the one that we've asked for, which would be the end vertex equals this, but end. Enter end vertex. And then, so we don't want, you know, we can be lazy. Let me just get rid of this. All right, so I'm going to be lazy here, and I'm going to go, well, V, is this going to be the letter? I'm looking for a capital letter, I think. No, I'm looking for a, V, okay, yeah, V is going to be a capital letter. So, let's see. So we've done that, and actually, what we just need, if we don't need the for loop, we just need to identify what V is. V is where we're headed, and we want V to be actually vertex of end. It's a letter, yeah, that's what we want. Oh, this should not be A, this should be start. Jeez. Maybe that's why I got that funny. Oh, that's why we got that. That's why we got this no path exists, because this was always set to vertex A, and we want it to be whatever the starting vertex is. In fact, I'm going to do this. I'm going to fix it. Not in vertex start. And let me run this now. C, G. Okay, yes. Okay, so now it doesn't say no path exists. No path exists just comes from this, and how could that be executed? But the total weight is 0. So this is the right answer. All right, so I fixed that, by the way. So this is what the question looks like, although it was ignored. All right, so let's go back to the code. Yeah, we can get rid of this line because we don't need to loop through all of them anymore. We're just interested in whatever vertex of the end is. And let's bring this back. And so instead of V, we want it to be called this, vertex of end. So and vertex of start is not vertex of end. As no path exists here. And start upper, we want this to be vertex end. And we want this to be vertex end here. And this to be vertex end. All right. Let's save this and let's run it now. So I'm going to go, I'm going to do C to F. No, I'll do C to G. If I do C to G, we should just get this last one. So C to G, and there it is. We just got the last one. All right, let's real quick see if this works. All right, I want to apologize. That took about 2 minutes, 2 full minutes, maybe 3 full minutes. But anyway, so this is the output. You see it tries random starting and destination nodes and checks to make sure that the answer is correct. And if it is, you get all the points. All right, so that should be enough of a help for the shortest path assignment. And you have 1 week from, you have until May 16th, Monday. So hope you can get it all done. If you have any questions, just email me directly. Thanks.